Okay, so I apologize for not having a camera on my work computer. I was not prepared for this working from home stuff. So that's what I look like, and also you saw my picture on the Teams. If you hear scratching, I have a dog, and he's very excited. Anyways, I'm a data technician at NASA's Goddard Space Flight Center. I worked on the Juno mission when I first started in 2016, and I've been with the Planetary Data Systems group since 2018. And I help create training materials and also do projects with machine learning. Here is my email. Once again, I will be sending you an email, so you'll have this sent to you as well. Unfortunately, also, I don't have an office phone because I'm at home. So, again, any questions, anytime, just let me know, and I will be sending you the slide deck after this afternoon after this ends. All right, so our goals for the day, we're going to go through the stages of creating this archive. And so one of the things is we're going to cover some terminology. PDS4 has its own terminology. You're going to see the task list that we have created that outlines the different steps of making this archive and which parts are your responsibility and which parts you get help with. And you can get help with any of it, but some parts are more your responsibility than others. And then we're going to cover some key points. So hopefully at the end of this, you're going to know the stages, know where to begin, know what step you need to do next, so you'll not get lost during the archive process. You're going to have a few best practices ideas to have in mind so that you know where you're going and what's the best way to get done what you need to get done, and also ideas on how to get assistance should you need it. Someone else needs to get in. I can hear it bing. Okay. All right. So starting off, like I said, PDS, like any other institution, has its own vocabulary. And knowing these terms will help when you communicate with your PDS personnel, and you will communicate with your PDS personnel. So let's cover some of the terms they're going to throw at you that mean something very specific within PDS. So first things is there are parts of a PDS4 archive. We've got our products, collections, bundles, lids. You see the list there, and we're going to go over these individually. So the basic building block of a PDS4 archive are its products. This is the lowest level, and you're going to build up from here. So most products are going to be a combination of one or more data products, so the data that you've collected through your mission or your study, and then an associated descriptive object, which we call a label file. And the label file, which we'll cover in a minute and in a few slides, is the way that tells you how to use that data product. Now, this is not always true. There are exceptions. A bundle, which we're going to cover in a couple of slides, and collections, which we'll cover in the next slide, and also context products. They're all products, and they also all have associated label files. They're just not data products. But most of your products will be data products. All right. Collections. So we have our products, and then we can group them together, and they can be related. That's the whole goal, is to find some organization that relates these products together into a particular collection. And again, a collection is a product also, and it has a label file, again, containing data about the collection. One of the things to notice here also, so if you look on the screen, can you guys see my mouse just fine?
Yep.
Okay, good. All right, so this is that label file. Label files are XML, and every collection is going to have an inventory file, and that's going to come up later. The contents of that inventory file must match the contents of your collection. If it does not, your archive will not be validated and will not pass validation, and therefore not be ready to submit to the PDS. One of the things to also notice in this particular, I'm using OSIRIS-REx as an example here, and so this is the data calibrated collection from the OCAM's instrument on OSIRIS-REx. And one of the things to notice is there are folders or directories within this collection. These are not collections within a collection. So that can be confusing for some. We've had that question before. This is another organizational level that you are able to include in your archive so that it makes it easier for you to understand the organization of your data and for people who want to use your data to understand it. So keep in mind you can do that, and you can organize your collections in the way that most makes sense for your study and your mission. And then just like we collected products into a collection, we then can collect collections into bundles. Again, a bundle is still a product and still has a label that contains metadata describing the bundle. So here's some examples of some bundles for OSIRIS-REx. You'll notice that OSIRIS-REx decided to organize their bundles based on their instruments. And then they have one larger overarching mission bundle describing the mission itself. And we'll get into the kinds of things that will go into there. You might notice here also that PDS4 has what we call a flattened organization system, meaning you can have several bundles and then you can have several collections within each bundle, but you cannot have bundles within bundles or collections within collections. It's very flat. One of the next things we're going to cover is the lids, and this is where you start to see the flatness of it. So another thing to keep in mind is that not all instruments have to be archived in the same node. And we're going to come back to this a couple of times. So even though you may have, if you have a larger mission, you may spread out your data across several nodes. If you have a small mission or small study, even if it's two instruments and like one's magnetometer and one's imaging, they could be at the same node. The nodes do talk to each other, they do share information, and they can talk to each other about the best ways to archive data that may not be their specialty. So it's not always about what kind of instrument you have that determines what kind of node it is. Sometimes it's based on the size of your mission. All right, so I promised you lids. These are logical identifiers. This is how PDS identifies each unique product within the whole archive. And I don't mean just within your mission or study archive, the entire PDS4 archives. So these have to be unique across the board. And generally that's not going to be too difficult. If you look here, just putting OREX on here pretty much makes it unique. And then beneath that stage of bundle, your collections are going to be unique because this makes it unique. OREX mission, OREX OCAMs, those make it unique in the PDS4. So this isn't like a very difficult hurdle to meet, but you do have to meet it. And we have some requirements. So again, they got to be unique, and they're going to be based on the hierarchy of each product relationship. And they have some limitations on what kind of characters you can use. And it's actually easier to say which characters are okay than to say which characters are forbidden. So it's going to be all lowercase letters. You can have some numbers, and you can have hyphens or underscores. So dash or underscores. But that's basically all you get. So these are going to be pretty simple. As far as, you know, laying them out, nothing too complicated. It's not like your password you need for your computer systems. One of the things to notice is your product ID here, and usually, again, this is going to be for the most part a data file, and that usually ends up being the actual file name. So when you start your schema, when you're saving your files during your mission, because you're going to plan for this before the mission starts. That's the whole goal, is to have this be part of the overarching mission. And so you can actually start to incorporate your lids and your organization of your archive within your directory structure as the mission goes on, if you choose to do that. You don't have to, but it can be helpful to have your data structure mirrored in the lids for the archive. It just depends on whether that works for you or not. Okay, and then we've got labels. So this is what you're going to spend most of your time on when creating the archive. So these are the how-to manuals for how your mission or data are going to be read. They contain key information on how to read that file, how to understand that file, and they define the context of the file. So they also provide metadata so that your data is searchable. Every word that you place in this label file is searchable. So the more you can put in here, the easier it is going to be for you to find, for people to find your data and use it in the future. And that's the goal, is to make the data available for future use. So we want to make it as easy to find and easy to understand as possible. So the more you can put in there, the better. Okay, so context products. This is one of the more interesting aspects of PDS. We need to include some context to your mission or study, but the actual context products itself are usually an idea or the object being studied or the instrument being used to study it or the spacecraft on which the instrument is connected. So while you may look at this and say, oh, but it's just a bunch of label files, well, that's because ideas and instruments and spacecraft and planets or dust can't be included physically in the archive. So these are the things that are going to actually describe what you're using, what you're studying. So if you look here, this is within the OREX mission bundle, and that's our context products collection. And so there's a description for the spacecraft. There's a description for each of the instruments. I don't see it here, but one would think there could be an actual context product for Bennu, because that's where it's going. Or I think that it's actually there. It's just picking out its place to land. And one of the things to also remember is that you do not have to create all of these yourself. This is one of the things that the PDS node is going to help you with. So if you're doing a Mars mission, the Mars context product is already there. You can reference it. If you're going to a particular place on Mars, you may have to create the context product for that particular location, but Mars itself will be there. So these are the kind of things to keep in mind. And then we have our mission or data dictionaries. So again, depending on the size of your mission or your study, this will influence the size of your data dictionary. And what we're collecting here is terms that you have a very particular meaning for. So like our definition of product is different than like your grocery store's definition of product or maybe Best Buy's definition of product. It's a very specific term. So if in your mission or study you have a term that could have a general meaning but could also have a very specific meaning, and you want it to have that specific definition within your archive, then you're going to want to include it in a data dictionary. And some data dictionaries already exist and are provided for you. So we already have spectral and imaging data dictionaries, radiometer data dictionaries. Most of your basic instrument types are going to be covered. But if you have something in particular that you need to have covered, you want to include it. And for smaller missions, this could be just a few key terms, whereas for a larger mission, it could be a whole set of data dictionaries that you need for your mission. Again, this is one of the things that the PDS node will help you create. All right, so now we're going to move on to our task list. So we have a better understanding of what terms people are actually going to throw at you when you start to talk to the PDS personnel. So let's actually look at what steps you're going to have to go through. And before we cover anything else, and we're going to cover this again, one of the things that we really want to get across is you're not doing this alone. This is not a task where you can sit and do it by yourself and get it done. And you can't just assign a grad student to sit and do him by themselves. This is one of these tasks where you have to contact your PDS node, and you want to do it before the mission, you want to do it during the mission, and after. This is also not a process that you want to wait to the end and do. You want this to be an integral part of the project, ongoing throughout your mission or study. Our goal, as stated here, is to preserve and share peer-reviewed data for the rest of the global scientific community into the future. So this is the only way that's possible is if it is a key part of your entire mission. You can't just leave it to the end, and you can't just wait till you're out of funding. You want to have funds for this. All right, so our task list. So the first three steps are kind of what you'd expect. You want to identify, what are we archiving? What are you expecting to collect in your data? So this is where you start to think about, okay, I have this type of instrument. It's going to collect this kind of data. This is the format that we may want to collect it in. Okay, it's got this kind of instrument, so we want some documentation about this particular instrument. Anything you need to describe your data that's going to go into that archive contents is what you're going to do in that step one. And then you're going to try and choose some kind of organization. So how are you going to put your products together? Are you going to do like OSIRIS-REx, where you created bundles for different instruments? Or does your study only have one instrument? And then you would have collections based on, so you have one overarching bundle and then collections based on the type of data. Do you have an orbiter? Are you going to have your collections grouped together by orbit, perhaps? I mean, there's a lot of different options. And you want to go ahead and start the task of assigning your logical identifiers to your collections, to your bundles, and then as your data products are created, they'll get them with usually the file name. So you want these three things to be kind of laid out before the mission starts. And having that organization decided and laid out before will help relieve pressure and prevent confusion when the data is being collected and when the team is ready to actually do the archiving. And also matching your directory and file structure to the one you decided upon for the archive. This can actually really help you know how you want to store that data, how you want to name that data. So these are things to keep in mind as you move forward. And these three tasks are done with the help of the node personnel. You're not going to be on your own with these first three tasks. These four tasks are more your meat of the actual archive creation. So this is your primary task. You're going to be responsible for designing the labels for your data products. Now, that's not to say you're not going to get help. You will, but the actual task of creating the labels as you go forward and collect your data products or your context products or, you know, all your other products, documentation, those are all going to be in your area. So this is where, if this is planning is done ahead of time, you'll already know what files you're going to need and what you're going to have. You're going to know what to name them. You're going to know keywords to be included within those data products or within those labels. And you're going to know already the format for the beginning of that label file, because all of that can be laid out. And we're going to cover this in a little more detail, but just some of the things to keep in mind, that just a little bit of preparation goes a long way in this process. And then these last four are mostly done with the help of the node personnel, mostly node personnel, and they're going to get your input on it. So those context products that need to be created, in the archive validation and peer review, all of that will be done primarily with the archiving node with your input. So the mission I decided to use as an example is the InSight lander on Mars. One of the reasons I chose it is because it has a very thorough and well laid out and easy to understand archive. And they've done a really great job on their documentation, and they have a really impressive data delivery schedule. So it's like a best case scenario. Okay, so that first step, like we said, was to define your archive contents. This is your data products, your documentation. This also includes your data dictionaries. All of this, again, completed with the help of node personnel. All right, so one of the things is choosing how you're going to organize your data and what you're going to archive. What data are you collecting? So there's a lot of instruments on InSight, and there's also several stages of mission activity. Now, InSight's a lander. It doesn't have an orbiter, so we don't have the orbits option here. But you got a lot of options and a lot of files to collect. So you can go a lot of different ways with your organization here. And again, remember, it's not just instrument data. That may seem like the most important thing to you, but it's not everything. You need to make note of your mission documentation, spice kernels. You need to document the mission stages, the spacecraft, the instrument, the planet, body, moon, dust, rings, whatever being studied. Context products are important. If you have a telescope, describe the telescope. If you have an instrument that you attach to that telescope, describe the instrument attached to that telescope. How does it collect the data? All of that information is important. Navigational information has been used for previous studies to actually do new things that weren't even thought of when the mission was originally happening. So this kind of stuff is important for the future missions, future studies using your data. All right, and the Insight Data Dictionary, again, Insight is a large mission, so it has a very large data dictionary. I'm including these, you'll be getting these slides, so you can click on these links when you get them, and you can actually see and scroll through what is included in Insight's data dictionary. So it's going to have the keywords and the formats that are going to be used within their archive. And when the validation happens, this is what we're going to check against. So you really want, if you do set up something in those data dictionaries with the help of your node personnel, you want to make sure that it is consistent throughout the archive so that validation will pass. If it isn't, then you'll get something called a lien, and we'll cover those near the end of the presentation. All right, now you know what you're collecting. How are you going to organize it? And again, this is completed with the help of node personnel. You're not on your own on this, so you'll get suggestions. So Insight did it by instrument. So here we have, and they had to do it at different nodes. It's a very large mission, as we stated. So keep in mind that this could happen. I don't know what all kinds of missions you guys are working on, but if it's a large mission, you're probably going to end up being at a few different nodes, maybe one or two different nodes. Just depends on the size of the mission and how much you're collecting, what different types of instruments are there. So remember that this is possible, but they have bundles for each of their instruments, and again, their SPICE at the navigational node. So keep that in mind, that these things are all important. One of the things also is that this may look intimidating, but even if your mission is spread across several nodes, the PDS main search allows for search by mission. So you don't necessarily have to keep track. I mean, you want to know who your node personnel you're talking to is, but if you wanted to tell somebody where to find your data, you don't actually have to keep track of what node it's at to tell them what website to go to search for it. The main page has a search where you can just search by mission or search by, like if it's a mission to Mars, you can search by Mars, and it will actually find that information, all related archives related to that. So you can do it by target or mission. You do not have to keep track of what node you're at if you choose not to. So again, what level of organization makes sense for your mission? So we got, you get instrument, activity stage of the mission, the dates of activity. You could organize it any way that makes sense for your project. What are you studying and how would it make sense? Remember, OSIRIS-REx talked about, had their instrument bundles and a mission general bundle. So you can actually have a couple of overarching organization schemes that, you can do it a couple of different ways. Like if you wanted to do it by orbit also, you could do it by orbit also, or you can save that for files within your collections. It's up to you. And again, we want to assign those lids to the collections and to the bundles and to the products as they come in. And this is with the help of your node personnel. So here's our requirements again. You want it to be specific, but not too specific. Notice that they did it on Insight by instrument. If you only have one instrument, you can have it named however you want, but you want it to be fairly specific, but not too specific, and also not too general. So one of the things to keep in mind is, like, if you're doing it by date, that you might get a little too specific. If you did it like a certain day, then you're going to have, like, if your bundle is a certain day, you're going to have a lot of bundles depending on how long your study is. So you might want to do by month, but you don't want to be too general either, in that you don't want to say, okay, this is my mission, my data. That's not helpful. You want it to be clear so that when someone comes to look for this data, they understand where they're going. So for like Insight Twins, okay, this is the raw data collection. And under that, I'm going to find files that are raw data. And here's a few more examples. So we got your data calibrated, data derived. They have a document one, so all their documentation about the twins instrument is contained there. And they also have an XML schema collection. And this is really good. So one of the things we're going to talk about when we get to labels is how each label is going to be laid out, you know. So in this case, they've actually defined what kind of labels they're going to need for each of the data types within these collections, and they've created basically templates for how to generate and validate these PDS labels. And they're including it right there so you could go and look for it, and if you needed to create a new one, it's right there. So that's a very good idea. And then of course they have their context products. So keep in mind this is their way of organizing it, but these are good ideas. All right, now for the part that's your effort. This is where you're going to spend most of your time. The nodes will help guide you, and they can help you create templates. Sometimes, you know, it depends on the node you're working with, but for the most part, this is what you're going to be doing. This is where you're going to be spending your time. All right, so PDS4 has schemas and schematron, and these two, well, there's several of them, but these two types of files contain a list of rules and definitions that ensure your label files meet the criteria needed for a valid archive. So they laid out the data types, the terms, what kind of entries you can have for each attribute within these XML files. And then when we get to the archive validation step, that's going to be the point where they actually ensure your files are accurate according to these schema and schematron files. So what you want in an editing software is something that includes schema and schematron validation. And there's a few options. And again, I have no vested interest at all in any of these software. These are just the ones I know about. If you have one that you like to use and prefer, that's fine. And as long as you have, so for the label files, we'll show later that it lists the location of the schema and schematron. As long as you have internet connection, it can get there and validate against them, you're golden. So this first one costs money. It's commercial software, but it does indeed support schema and schematron validation out of the box. So there's one option. Notepad++ is free, and you can download a plugin that supports schema and schematron validation. I have not used Notepad++. I do not know how to use it. NASA bought for me the Oxygen software, so that's the one I'm familiar with. But Notepad++ does have it, so that is also an option. Eclipse has schema, but not schematron validation, and it's also free software. So if you feel comfortable with that and the potential for some liens later on your validation, you know, that's an option. But keep in mind that it may not be validating, or it won't be validating every single part of your label file. But again, it's your choice. And again, all of these softwares will highlight XML errors because that's what they are. They're XML editors. But not all of them validate against a schema and a schematron. Okay, so parts of a label. So the first line, as mentioned before, it points to the schema and schematron. So you've got your, and there can be more listed here. This is just an example, but this is the literal address onto the internet where it can find them and check against them. So this is at the beginning of every single label file. One of the things you can do when you go on the PDS website is you can download example label files, and depending on the internet browser you use, for instance, if you use Chrome, it cuts off this beginning section sometimes. So like especially this beginning section. So keep in mind, if you want to see the full thing, you have to actually tell it to show you the full file. I mean, that's the only part it cuts out, but But every label file will have this, and the only changes that will occur is if there's a newer version created, or if you have other schemas and schematrons related to the particular type of file that you are doing. So like there's a display dictionary one that might be here if you're doing an image file, or a document one if you're doing a document. And after that, we have the identification area. So this is from one of the Insight product labels, and one of the things you can see here is here's our lid, our logical identifier. And again, this is the file name, like we mentioned before. And obviously that's pretty unique. But anyways, they chose to use, this is probably the file name as they collected it, and it contains information that describes the file if you speak Insight language. I don't know all the particulars on what this means. So a lot of this stuff in the identification, when you're creating your templates, can actually be entered in, like you can have a placeholder here for the file name. So you can already put in observational product and then have a placeholder waiting here. These kind of things are not going to change. And again, you want to include in here your metadata. So anything you want to put in here, like comment, is usually a optional entry. So you could put in here key search terms that you expect other scientists to look up and try to find your information using. So keep that in mind. Most of this stuff, like I said, you can pre-fill out, and then as the files are created, fill in the file name, fill in any particulars that match just this file. That will save you time. And this is the big area. And so this is where and this is particularly an observational file, so it's not going to be the same for every type of label file, but this is where you're going to get a lot of information. And it looks scary because I could expand all these out and they would have lots and lots of information. But one of the things to keep in mind, again, is that a lot of this stuff is going to be repeated. So sections such as the primary results summary, the investigation area, and the observing system, but probably going to have the same information across this entire collection. So differences are going to be a good divider into what kind of collections, what collection is this going to go to, what bundle is this going to go to. The things that will change that you will have to fill out are, time coordinates. So each file might be probably collected at a different time. So you'll want that kind of stuff you'll have to put in. But most of the other stuff is going to be repeated. So even though it looks intimidating, just keep in mind a lot of this stuff is going to be repeated. And then the last part of our file, our label file, is the file area. So this is going to describe the actual file itself, not the contents, but the file itself. So in here, these things are probably going to vary. So you're going to have your file name, when it was created, how large is it, things like that. There's some things, of course, that will be similar. Like if it's the same, they're going to all be probably the same camera. So a lot of this stuff will be repeatable, but especially as you go down through this the array 3D image part, and they might all have a very similar header, so this kind of stuff might be the same, but some of the file sizes and obviously the creation time and the file name will be changed as you go. So also wanted to tell you that we are in the process of creating instructional videos to help with this label making process. And one of the things I'm going to email to you after this workshop is a link to these videos so that you can look at them and let us know if you find them helpful. Right now, they are all focused on imaging files. So we've got one on display settings, and we've got one, and we're covering an array 2D image file. But we're working on fleshing that out and getting more examples. Since this is the part you guys have to spend most of your time on, we want to help you as much as possible with making these labels. And so our goal is to make a very good product that can make your science more accessible. So we welcome any feedback. You're going to have my email address. Feel free to email me any thoughts you might have, any ways to make it more usable for you, suggestions for future video topics. That would be great. But I'll get those to you after the workshop. And we've been talking a little while. Does anybody have any questions or need to take a break? Okay, we will charge forward then. Okay, so the best thing to do is to develop a procedure to make these labels happen as easily as possible. So again, like I've been trying to tell you, a lot of the parts of these labels are going to be identical for your groups of products. Templates will help. And then once you have the major templates set up for each product type, then you can fill in the things like the file name and the file size. And the PDS has created tools to help you with this effort. So here is an example template. And we're going to zoom in on that because it's very tiny. All right. So again, creating a template for each type of label file will speed up the process. This template was actually created by the Atmospheres node, and it was for the study Sodium Coronagraphic Observations of the Lunar Exosphere. So this template is for a document label, and as you can see, there are entries that are the same throughout each document in this collection. So again, the information model version is not going to change. Product documents not going to change. The authors are not going to change. The editor is likely not going to change. You're hopefully going to get most of it out in 1 year, but if you don't, if there's a long mission, that might change. What you're studying is probably not going to change. And then you've got your description. So for a whole group of files, of label files, these are going to be very, very similar. This particular one has to do with a user's guide, so that's kind of nice. And the descriptions are really nice. Again, this is an area where you can include more keywords to help make this more searchable and more findable by people who need to use, for instance, this user's guide. And again, there's our logical identifier letting us know what it's looking at. So this is a pretty not too specific, but it's a pretty good one. So we got your moon, sodium, corona. That's pretty descriptive on for the bundle. And then it's in the document collection, and this particular document is the user's guide. So that's another example of what you can use when you're thinking about creating your lids. Getting these templates started early will really help you. Some nodes do help you create templates, and some nodes refer you to softwares. And so here are some softwares that help create templates. So we have some options, and which one you use generally has to do with which node you're working with. So for instance, if you happen to be working with the Atmospheres node, you might want to use ELSA. So this one will help you create label templates. If you're working with the Cartography and Imaging Sciences node, they have GDAL. This helps create label templates. But if you want just a general label template software, AppsPlad is created by our engineering node, which is kind of the overarching node that provides kind of the structure of the PDS. So this one would work for any node that you wanted to archive with. And all of these are going to be pretty generic. For very, very specific things, you want to talk to your node personnel. If you have specific questions on certain types of labels, talk to your node personnel for any questions you may have. Also, you can email them to me and I will get you to node personnel if necessary. But hopefully by this time you have a person that you talk to. That relationship needs to be close enough that you feel like you can go and ask them questions. So now you've got your templates created. We've also created softwares that can help you add information to those templates for each file. So some of them are really nice, like this one. They're all really nice. I shouldn't say. I don't have any particular advantage on one or the other, but I happen to really love Excel spreadsheets. So making an Excel spreadsheet of what's inside your particular product files and then moving them into a label template appeals to my sense of order. So I happen to like this one. But if you're working with the Geosciences node, you've got two different ones, DocGen and Make Labels. And both of them use a template, and then you can read in your data product information. And then again, the engineering node has created this one called Generate tool that will also read in from your template and put in your data product specific information. And then if you're working with the small bodies node, there's a tool called Olaf that actually, it does create labels, but it does it part of an overall archiving process. So it's more of a larger package, and it's pretty basic. So very specific things, you're still going to have to ask questions, but it's a good tool, and if you're working with the small bodies node, it's especially good. It's one of the things that could be fleshed out to work with more nodes, but we're still working on that. So there you go. That's an option. All right, and now we need you to actually document your archive. We want you to tell us what's in here. What are we studying? What is this instrument? What does it do? Tell us all about it. So again, Insight has some fantastic document collections. So so it is an entire document bundle, and each instrument is documented. The SPICE collection is documented. There's a document all about the mission itself. This is a good example of a documented mission. So we need to know these things, because the scientists in the future may not be able to go back and ask you how the data were collected, how were they processed, what did the data mean, what were your goals, what is this data, and are there any limitations on your data? These are the kind of things that we really need to know. What were you studying? What in particular about, like for Insight, what in particular about Mars were you studying? What was the point of this particular instrument on this particular mission? We need to know about the target. We need to know about the method. All of these things need to be documented. And every document, remember, is also a product, so it will have a corresponding label file. Everything in PDS has a corresponding label file. And then don't forget your context products. Very important to cover your context products. Again, there's one for Mars already, but the specific spot on Mars that Insight landed probably didn't have a context product before they thought of this mission, so they had to describe that. Each of these instruments, the spacecraft itself, everything about this had to be described and has to have a corresponding label within the PDS archive. Okay, so now we're at the step where you've collected everything, you've delivered it to the PDS node, and now we're going to try and validate what you've delivered. Now, this is an ongoing task. This is not done at the end in one big bunch. This is something that you want to be doing throughout your mission periodically, so that it isn't overwhelming at the end. Again, big part of the mission as a whole. So a lot of scientists will use whatever software they're already comfortable with to look at their data. That's a given. That's just the way it is. But for the PDS archive, we need it to be able to look at the label file and read the data directly. And just because you guys don't do it that way within your mission, you guys probably don't do that. So we want to make sure that the label files tell us how to read your data. And so the data may look beautiful to you in your software, but we need it to look beautiful in ours using the label files. So we want those labels to validate, and we need the data in the archive to be readable using tools that read from label files. That is a big part of our process. And we have tools that you can test this with. We have a PDS4 viewer, and I believe there's also one called PDS viewer that you can test occasionally to see if that's going to work. And it also includes checking that your products and collections are accounted for in those inventory files that I showed you early on. So remember to keep up with your inventory files in those collections. As you add data products, add them to your inventory files so that all products are accounted for and they resolve as we're checking and going through the validation. And then you'll go through a peer review. So this is managed by the PDS node, but it does involve you. Your opinion will be taken into account, and we'll bring in 2 outside reviewers, and they have the following goals. They want to make sure that your data are understandable, that your data are readable, and that it's useful. So they will use software to read the labels, to read in your data using the label files, and then they'll try to do a little bit of science with it. And they'll only use the documentation and references within your archive to see if they can produce usable results. So while they may know, like for Insight, they may know a lot about Mars, they're not going to reference that outside information as much as possible. They're going to try and limit all of their investigation on your data to what Insight has provided, to make sure that a future researcher 100 years from now who won't necessarily know what Insight was studying beforehand, they'll look at it and say, okay, this is what it's doing, this is the description, this is what I should expect, and there it is. So that's the goal. And then each of the reviewers will prepare presentations with recommendations on whether this data is usable. And if there are things that are missing, if there's documentation missing, or maybe some files weren't accounted for, then you'll get something called a lien, and that needs to be resolved by you. So within this review, you're going to have a discussion. It's not like you're just going to hand it off. There's going to be a discussion on how to resolve these liens. And so usually it ends up being some kind of extra documentation. You know, as long as you don't have to modify the data, you just get to do a little delta review and then make sure that what was missing is provided, and you're done. But if there is something going on with your data, like something was misaccounted for, or data files were being read wrong or backwards, like in an image file, then they're going to have to go through an entire full review again afterwards. So this is one of the things you want to keep in mind throughout the mission, is to make sure, if you're, especially since you're going to have those templates, for instance with the image files, that each of those is typed up correctly. And so, because then errors will multiply out through the files if you don't have that already correct within your templates. And as you're submitting your data to the PDS, the PDS can help you set up a delivery schedule. So in large missions, it can happen in stages. But if you have like a small mission, like you're just studying one thing for like a couple of months, you may deliver everything at the end. But keep in mind, ongoing for larger missions or for extended time missions is better. It's just easier to fix things early on instead of having them all replicate throughout the study, and then at the end you'd have like a huge amount of liens to fix. So this is the release schedule for Insight, and it's really ambitious, and it's a really great, I mean, you collect the data up through February and they have it out to the public by May. That's a really tight schedule. It's really impressive. And they've been meeting this schedule. And they've been meeting the schedule because they planned. They planned ahead. This is what's possible. If you do it right, you can actually get this set up so that the archiving process goes cleanly. Plan ahead, plan ahead, plan ahead. This is what you want. All right, so our ultimate goal is immortality, right? We want our data to be available for the rest of time, for as long as computers exist, for as long as we're studying the solar system, before we move out to a new solar system. But then we'll have more data to collect. So here's a couple of examples that, you know, when we say like 50 to 100 years from now, you don't think that we're being ridiculous. So a couple of scientists actually in my building at NASA, Gina DiBraccio and Dan Gershman, actually used Voyager 2 data to discover new magnetic field properties of Uranus. 33 years after the data was collected, it's still usable, it's available. That's what you want. You want to use the data for as long as possible. So again, one of the things I don't know that I mentioned, but one of the things the PDS requires is a specific data format, and that's going to be discussed with you by your node personnel in particular. So I don't have particulars on that. Each node has their preferred data format that they want things to be in, and it's going to be as basic as possible so that it's not doesn't require a specific software to be read, because that software may not be available into the future. You don't know what's going to last. So we pick the most basic possible so that it lasts. Another example, in 2018, Rosemary Killen et al. Was able to use Apollo 17 data to write their paper on the lunar neon exosphere seen in LACE data. And that was in the journal Icarus. And there's links in the notes when I send you this. You can click on these studies. But that's 46 years after that data was collected. That's the kind of forever usage that we are going for. This is what we want. Your names will be immortalized in your data. So make it as readable and as clear and as well documented as possible. That is the goal. And again, talk to your PDS node. Talk to them early, talk to them throughout, and then certainly as you get closer to getting actually all your data collected, you want to make sure you're in constant communication so that little things don't get in the way of getting this data out in a timely fashion. Our goal is to have, again, peer-reviewed, citable data for the entire global scientific community well into the future. All right, so final thoughts. This is where you have to actually speak back to me. So unmute your microphones. You guys didn't ask any questions. So did any of you have any surprises with this process? Anything that you didn't expect? Silence is consent. Okay, so you were good. All right. At the end of this, is there anything you can commit to doing to make sure that your archive is the best archive it can be? Can you commit to maybe identifying your archiving node? Can you start getting your mission and study documentation together? If nothing else, can your mission agree on a time and data format that they want to archive in? And do you guys have any questions? Is there anything else lingering for you about this process that that I can answer? And again, you can email me. I'm not gonna make you talk here. I've talked a lot, so. Okay, all right. Well, if nothing else, we'll back up your data, so you don't have to actually lose anything. So that's the end of my presentation. If you guys have any questions, feel free to email me and let me know. I will forward them on to whoever can best give the answers. And yeah, just let me know.
Hi, Sherry.
Hi.
Nicholas here. Can you hear me?
Yes.
I thought it would be nice for you to hear a voice back before you close on them.
Thank you.
One of the co-organizers of the Open Planetary Virtual Conference, and I've been myself for many years archive scientist for the European Space Agency, so I'm very familiar with the process. I haven't been doing this for quite a few years now, but I just wanted to comment that your talk was amazing from the perspective of a data provider. I think that is so helpful.
Oh,
so
thank you. Thank you very much.
Can I also ask a question?
Absolutely.
Hi, I am Mario. I'm from the German Aerospace Center. I'm working on PDS4 dataset for our instrument on the Bepi Colombo mission flying to Mercury. Okay. And my question is, so your talk was really nice. So I know a little bit of this PDS4, trying to produce a new dataset, but it's always useful to get a refresh. Now my question is, every time I talk with your PDS guys, we are talking always about the nodes, but we are coming from other space agency. We don't have, maybe Nicola could comment about that. We don't have this node concept like you. So if we are coming from another institution abroad, should we approach to one of the nodes? Or, I mean, it's always a problem because we are not in your funding schemes, or are not really sure how to organize our data in the MESA storing in the PDS node scheme?
Right. Well, like I said, I used to work with the Juno mission, and I know that, like for instance, the GIRM instrument was based, I believe, out of Italy, and they are able to archive within the PDS node, and I want to say that they were on the PPI node.
Okay.
So I believe they did have continuous and still do have interactions with the node to help with their archiving. So you should be able to contact someone. If you're having difficulty, I can, if you send me any particulars about your instrument, I can try to get it to whatever node you may, so you can have a person to talk to in particular.
Thank you. I'm pretty sure that the guys, sorry, Nicola, go on.
I was going to say, yeah, on the European side of things, we have the ESA's Planetary Science Archive, which acts as the archiving authority for the European Space Agency missions. And I just wanted to point out maybe the International Planetary Data Alliance, which is a gathering of all the different agencies beyond NASA and ESA, but also Indian and other space agencies that can, that meet together to discuss standards. And so that might be a good point of contact for one of the data provider who doesn't belong to NASA's program or ESA's program.
Right. But at the end of the day, for the validation of the data, we always refer to the scheme that NASA and PDS are producing. So I know that the guys at the PSA are in contact with the PDS and try to develop a custom dictionary for the mission and for the instrument. A few, but we need special things that should be included in the PDS release.
Yeah.
So yeah, thank you.
Ultimately, it depends where the data will be archived and who's responsible for it.
Right.
So.
All right. Great, thank you. Again, if you have a specific, like if you need someone specific to contact, I can definitely get you in touch with node personnel. So keep that in mind. I'm not with a particular node. I don't know if I said that before. I'm with the what we call the project office, but we all interact and talk fairly often. So it's not difficult to get a particular person to answer a question.
Thank you.
You're welcome. All right. Well, I think I'm going to stop the recording. Thank you guys for allowing me to record that. And